All right, this video is going to go over two-stage gas heating and how do you check two-stage gas heating and some of the things that you need to do or need to be able to learn how to do to check to see if your negative pressure switch is actually kicking in properly. Are both of them kicking in? What causes your gas valve to kick in first stage, second stage, things of that sort. All right, let's start off with a two-stage gas heating system. Now, could I have a single-stage air conditioning system with two-stage gas heat? The answer is yes. Because it could be a two-stage gas heating system with a split capacitor motor for the blower motor, which today, 2023, they're not going to be making in 2024 any more gas furnaces with split capacitors motors. They're all going to have X13 blower motors from here on out because of the efficiency standards are going up, and therefore they're not going to make any of the split capacitor motors. Actually, in 2023, they stopped making them. So air handlers will not have any more split capacitor motors. They're all going to be the X13 motors because the efficiency rating for SEER is now going to be SEER2. That's the way the efficiency rating is going to start rating efficiency for air conditioning is going to be SEER2, which puts the line right down the middle of saying, here's the way we used to do SEER ratings, here's the way we now do them. It's just stupid as the government. Instead of just saying our minimum efficiency has raised, they changed the way they calculate the ratings. So you can have a two-stage gas furnace because it's just a two-stage gas valve. That's all. So you can have a single-stage air conditioning system with the X13 blower motor. It could have a variable speed blower motor as well. And you could have two-stage gas heat. And you can have a single-stage air conditioning system and everything works fine. So it don't have to be two-stage and two-stage. It's just how you match that system up. I may put a variable speed furnace on a specific installation because I know there's nothing I can do about the static pressure problems in this system because the duct system is embedded in the walls and I know I can't do anything about the duct system and it's a high static pressure. If I put a system that's got a variable speed blower motor in it, 90% of the time it's going to have a two-stage gas heating system, fine. But that variable speed blower motor will increase the velocity of that blower motor basically to force the proper CFM that I need in the duct design of that system, okay? So this one little two-stage thing can go into why would you put it in there. So two-stage gas heat is checked like this. You turn your heater on. First thing you're going to do is you are going to energize from R, W1, and W2, okay? So when on your thermostat, if you set your thermostat at say 70 degrees, when it reaches 69 in the house, R will turn around and energize W1. If you have a 100,000 BTU furnace, okay, that's input, your output is 80,000 BTUs, okay? So we're just gonna deal with the input because it's easier to divide and all that kind of crap. So how many BTUs will you get on the first stage of that heating system? Approximately 70%. So I will be first stage somewhere around 70% capacity, 70,000 BTUs, okay? On second stage, I will get 100,000 BTUs. Does that make sense? In order for me to get 100,000 BTUs, then my thermostat would have to drop down to 68 degrees, which would energize W2. If I energize W2, then what I'm also doing is I have a two-stage induced draft motor, IDM, right here. So I've got my neutral wire, and then I've got a high speed, and I've got a low speed. The only thing we've talked about so far is an induced draft motor with one speed, right? Well, now we're going to get into something different. Now I got a two-stage heating system with an induced draft motor with 3 wires to it instead of just applying 120 volts. Now what speed is it on? The blower motor, induced draft motor, will actually pick up its speed. If it picks up its speed, the induced draft motor is measuring what? What is it doing for you? Negative pressure, right? So out of this tube right here, you're going to measure negative pressure out of this tube. If the induced draft motor is working on low speed right here, and this is negative pressure switch 1, and this one is 2, and this one here is at a negative 0.3, and this one's at a negative 0.5, then when I'm running in low speed, I may be between negative 0.3 and negative 0.5, and only this pressure switch will kick in. So I've got a normally open switch here. So if I'm reading on low speed negative 0.35 on here, I'm not going to pull in my second stage heating, right? Or my second stage negative pressure switch. Only this one is going to kick in, which is going to send a signal. Here's my power wire right here, 24 volts. It's going to come back to my circuit board right here, and it's going to go W1 on my circuit board. Boom, I got power coming back here, so it's going to say, okay, here's my gas valve. Gas valve has got my neutral, and then it's got stage 1 and stage 2, okay? So stage 1, my circuit board says, okay, stage 1, I'm clear with this part of this. Go ahead and energize stage 1 for the gas valve. So stage 2 is going to be 3.5 inch water column pressure. Stage 1, I'm making this part up. I don't know the exact answer. I'm just going to call it 2.5 inch water column pressure. Okay? So stage 1 energizes, gas shoots out, which also simultaneously is going to energize what? My spark ignition, right? My spark ignition is going to go ahead to my burners up top here, right? So there's my burners. Right here is, I have a spark ignition right here, and that sparker is going to spark. Gas is going to shoot out at a 2.5 inch water column pressure, right? Which instead of having a high, it's going to be just very low gas pressure. That low gas pressure is going to come in here, boom, shoot out. Each one of these is now going to ignite, and I have approximately 70,000 BTUs worth of heat. Okay? Now, stage 2 energizes because it can't handle it. It goes from 69 to 68 in the house, which energizes W2. When you energize W2, it tells the circuit board, hey, I need more heat. So the circuit board right here goes, okay, W2, let's send voltage over here to a relay, which is going to now turn in high speed fan, turn off low speed fan. Induced draft motor picks up its speed, therefore creating more negative pressure in here, because now this one needs to pull in at a negative 0.5. Now that the negative 0.5 is pulled in, and this is also a normally closed switch, right? Normally open switch, excuse me. It's going to pull this switch in and close it, which is now going to say, hey, circuit board, W2 has energized. Negative pressure switch 2 has energized. My safety features are all closed. Everything's good. I don't have to spark ignite anymore, right? That don't have to be done, but what has to be done now? Hey, W2, energize W2 on your gas valve. Release that gas valve completely now to 3.5 inch water column pressure, and now I get more gas out of here. My induced draft motor has picked up its speed. Hey, circuit board. W2 is energized. Let's come over here to my blower motor and let's say, hey, blower motor, let's throw, instead of, I'm making this up, instead of throwing 600 CFMs of airflow out for the first 70,000 BTUs, let's go ahead and kick it up to 900 CFMs of airflow. And this is all just made up, just giving you a thought process. Let's kick the blower motor up to 900 CFMs of airflow. So we have 100,000 BTUs coming out of here. Fan motor picks up its speed. It may be 1,200 CFMs or whatever. Okay, this is all made up. Now I get my proper delta T. My negative pressure switch is pulled in on 2. Now what happens if I have a bad negative pressure switch on number 2? Induced draft motor picks up its speed, right? And you actually hear the induced draft motor pick up its speed. There's one hose here, it's not 2, right? So it's not like you're checking a whole nother hose going to here. So you know the negative pressure switch has got to be good because my induced draft motor is running, my flame is running. I got energy to my W2, but you're hearing the gas pressure, and that's why you got to listen to your gas pressure. You got to know what 3.5-inch water column pressure is. That's why you got to listen. That's why you can stand by that furnace, and the more you keep standing by that furnace on a good brand new furnace, you know what that flame sounds like. Now you go to this one, you turn it on, and you hear low gas pressure. First stage. You hear the induced draft motor come on. Fan motor is just running quieter because it don't need to pull in as much negative pressure, right? High speed comes on the induced draft motor. You hear it pick up speed when W2 gets energized. It pulls in harder now, but yet your gas pressure doesn't change. If you have a manometer sitting on your gas valve, so here you go, here's your gas valve. Alright, so coming out of your gas valve, this is going to your burners over here. Alright, you put your manometer right here and it's coming out. Oh, there's your manometer. And you're reading 0.35 inches in water column pressure. Okay. Meter. W2R, common and W2, I got 24 volts to it. Induced draft motor is running at a higher speed. I go look at my speed, I actually can test my lead, let's just say, and I go, boom, high speed is energized, but it don't ever sound like, and I just verified that I'm only getting 0.35 inch water column pressure out of my gas valve, 2.5. Not 3.5, 2.5. Because we said earlier that gas valve stage 1 is 2.5 and we're saying stage 2 is 3.5. And that is for argument's sake, that's not an exact. Well, gas pressure, this thing is still not running. You go, I can't get this thing to kick in second stage. It has to be a bad gas valve. Well, I go check my gas valve itself from my common to my 2, and I'm not getting 24 volts to the second stage on my gas valve. Why am I not getting 24 volts to my gas valve on second stage? Simple. Because my negative pressure switch on 2 has not kicked in yet. It will not energize it. My blower motor never picked up its speed either. So my blower motor is still running in first stage. My gas valve is still running in first stage. I have heat. Customer's not complaining because that whole 2 weeks of cold weather we have, it was still enough to heat their home. But I'm there to do a heater check and it never kicked in second stage. So how do I test, and this is where this whole program came from, this one thing. How do I test that this should be kicking in properly at negative 0.5 there? I can actually come over here and I can put a T on my line. Okay? And that T will then do this. Okay? And then I can hook my manometer. I'll bring my manometer over here. Okay? And here's my manometer saying 0.035 inches in water column pressure, and I'm going, let me read my negative pressure switch, and it says negative 0.5 is when this one kicks in. This is running at high speed though. I tested that. What's my problem? Clogged line. You got something in your induced draft motor not allowing that negative pressure to be pulled. So what do you have to do now? Or no?
Open up the housing and just check inside of the housing. Check your
There you go.
hoses as well.
There could be a bird nest in there, a wasp nest in there, a dirt diver nest in there, a coupling, debris, chips of wood. How about your vent pipe could be clogged up?
Yeah.
Partially clogged up to where you're only getting a negative 0.3. Okay? Blower wheel could be shit on or whatever, okay? Falling apart. I've seen that. I don't have as many today, but yeah. So it has just enough to get you 1, but it don't have enough to get you 2. The little pinhole where this hole goes into, that could be clogged up partially to where you're only getting it. Blower motor's running at high, but if you got a clog in there, it's not allowing it out. So you're on the right track. Here's what you go check for. So we've never went over a 2-stage heating system. Now do you understand how 2-stage heating works? Everybody?
Yeah.
Any confusion? So who wants to get up here and erase this and redo it? Anybody? Alright? So this will also, I'll make a video with this to where everybody understands how 2-stage heating works. Okay? Now, what if you go over to your thermostat and you see W1 and W2 are jumped off? What's going to happen?
This is gonna stay on first stage. Right?
Nope.
No, it's gonna come on. It's gonna come on in both stages.
It's going to come in first stage first for a short period of time, and then automatically, like when I say a short period of time, 5-10 seconds or whatever, 15 seconds, and then automatically kick in the second stage because you're jumping it off. As long as the induced draft motor and W2 is energized, it's going to kick in W1 first, and then all of a sudden it's going to kick in W2, okay? And then that's going to induce it, cause the induced draft motor to run faster, which is going to pull in negative pressure switch 2, which is going to tell everything else. But one's got to pull in first. Why? It's giving you the okay with all the rollout switches and all that kind of stuff. It's going through all that because you can't run 2 without running 1. If 1 don't kick on, 2's not kicking on because the safety features are in 1. That makes sense?
You gotta get past all that.
You gotta get past 1 before you get to 2. So if only 2 kicks in and negative pressure 1 says, I'm not closing, then it ain't gonna work. Alright? That makes sense. Do you need a different size vent pipe for 1 and 2? No. Different size gas line? No. Do you need a 2-stage thermostat?
Yes.
Yes. Okay. Alright, so this is 2-stage gas heating. If you want to learn more about just heating and what we're checking in heating, our PMA fall for gas furnaces is what you actually need to watch first. This is a secondary for gas heating to give you a little bit more in-depth in 2-stage gas heating. Check that video.